Hi there and welcome to the fourth video in the series of doing shooting with Unity3d and raycast projectiles. Now, firstly I'm going to start with an apology. You may have seen in the comments of the last video I actually made a mistake in my check hit function, so if you haven't changed this already, the line 2 here of the check hit function says last position and then transform.forward, and it should say transform.distance. Transform.position. I got it wrong again. This is basically the ray. It's the transform.position is where it is, and the last position is where it was last frame, and then you cast this ray and check whether it hits anything. Just that one change alone, you'll see that when you play this, the ray should go all the way into the object that it hits, and it looks a lot nicer, and it doesn't matter where this object is, you should see that it still goes straight into that object. I was playing around quite a bit with this as well, and I also moved the check hit to be above the movement thing, and I got a better result from that. So if you change that around as well, it should be a bit nicer. Now on to the topic of this video. What we're going to do, as you can see from the video, when we actually play this, the particle systems, the bullets, they all get spawned in and they get removed again, and that's actually a really inefficient thing to do, particularly in C#, because you'll get some spikes later on when the garbage collector has to dispose of all of that memory. It keeps it for a while and then it gets rid of it, and often that can cause problems. So we're going to use a system called pooling. So we're going to create a brand new class to pool the bullets so that they don't end up taking up that valuable memory. So we allocate them once, and then we can activate and deactivate them. So we'll get straight to that code. One of the main things that we have to do is we need to not destroy the game objects. So in the bullet script here, we need to not destroy these game objects. So we need to actually find a different way of doing it. And what we need to do is we need to deactivate them rather than destroy them. So what I've done is I'm going to check this line out here so that we don't destroy the bullet. And in order to destroy it after a second or so, what I've done is I've created a couple of variables. So you can see here it's float lifetime, and you can set it to any value you want. You can set it to 1, and then float age. And what we're going to do is we're going to create a function inside here. We're going to call this void, and we're going to call it check age. This check age function is literally going to just see how old it is, and check age we're going to call from inside the update function. So this check age is nice and simple. It's just going to see if it's too old, then deactivate it. So it's nice and simple. We just say that the age equals age plus time dot delta time, and then if the age is greater than the lifetime, then we basically deactivate the object. So the way to deactivate the object is to we say gameobject dot set active and then say false, and that will deactivate that object. One little problem that we'll find when we deactivate this game object is that the age of it is it stays as it was, so it holds that information. So what we'll do is we'll also write up here, we'll also write the void on enable. The on enable allows us to, when we've deactivated it and reactivated it, this is like a new start function again, but only when it's been reactivated again. So we're just going to say that the age is equal to 0 when we reactivate. That'll make sure that it doesn't stay dead. And one little other tidy up as well is that we've done this inside the start function, but I think what we'll do is just completely get rid of the start function, and we'll just allocate this up here. So we'll just say we know how big the cast hit array is going to be, so we're just going to biff that up there, so we don't need a start function at all. I'm just going to put some comments in. Off the bullet, there we go. So yeah, that's oh no, that's not pretty much it. The last thing is we've destroyed it down here, which is also not a great thing. So again, we're just going to do this gameObject dot set active false down here. So they will become inactive rather than being destroyed. Let's just test this just to see. The game won't be obviously functional right now because they'll be deactivated. So you'll see that the bullets, when they hit something, they're still here, but they're being deactivated. So you can see that all of the rest of this stuff won't get run while the bullets are deactivated, and our job would be to just reactivate them when we need them. And that's more or less it. Now comes the complicated part. So what we're going to do is we're going to get the gun to make a pool of objects, and this gun is going to hold a certain number of those objects so that we're able to just activate them and deactivate them when we need them. So we're going to need a new C# script, and we're going to call this pool, and open it up. Alright, so this class is an interesting one. We're going to delete these two at the top. We're going to leave using Unity Engine, but what we're actually going to do for the first time is not inherit from mono behavior. So we don't need a start and an update function. This class is going to be more or less a C# standalone class. Now the way that this works is that I'm going to make the constructor for this. So the way you do a constructor is basically a start function in Unity, but it's for a C# class. And when you say new something, so if I do a new pool, it will run this piece of code in here. The parameters I'm going to take for this constructor, I'm just going to do one. I mean, I could do multiple constructors with different parameters, but this will be the basic one. So I'm going to need the game object that I want to spawn, and I'm going to need the number of objects that we want in the array. And that's more or less it for that. We're going to then create an array of that number of objects and instantiate that game object in it. So we're going to need a game object array, obviously, to hold these in. So a game object array, and I'm going to call it game objects is with a small g is good enough, and close that one there. The last thing is I'm probably going to want to store how many objects it has, so I'm going to say number of objects, make that one equal to 0 to initialize. Alright, so when we call this, we're going to create that game object array. So we're going to say game objects, that's R1, equals new game object array of size number of objects. Cool. And then for every single one, so if you type in for and double tap, we use for each loops quite a bit, but I would need to be able to access index into this array, so I'm just going to do it this way. Oh yeah, the last thing one of the things I need to do is that the number of objects should equal the number of objects. So I know that sounds really weird, but I think what we'll do is use my old school method from the C programming days. So this is the member variable, just so that we know. So I'm going to set our member variable to be the value that is passed from the constructor. Okay, so we want this to be a number of objects, and save. And then for every single one of these, we want to create by instantiating a game object into it. So I'm just going to say gameobjects and then I, so this will go through each one, and the index will be stored as I, so I'll start off with 0 and then 1 and then 2 and then 3. So gameobjects I is equal to instantiate. Oh yeah, when I was doing this before, I found out that this weirdly doesn't do it until you do gameobject instantiate. So yeah, gameobject instantiate, and then the name of the type or the gameobject that we want to instantiate. The last thing we also want to do is make sure that this gameobject is not active, so we use the setAct false, so that when we instantiate it, it's not actually active, because we're going to activate it. So that's pretty much it. If we save this, we should be able to use this inside of the gun. So I'm going to jump back to the gun script, and what I'm going to do is I'm going to create this pool of objects. So I'm going to say pool, and I'm going to call them bullet pool, like that, and then inside of the start, perhaps we'll say bullet pool equals new pool, and then we pass into it the bullet prefab that we have, so the bullet prefab, and then we'll just for now make 10 of them. Saving this code and running it just to test, we should see that when we hit the play button, the gun script should create 10 bullets and all of them are deactivated. You can see from here that this is actually what's happened. Is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because I told it to, and they're all deactivated, and they all contain all of the information that we need. So all we need now is to more or less write our own instantiation script that will activate one of these, the first one that is available to us, and then we can, instead of this line here where we instantiate the bullets, we're going to use our new pull function that we're about to write. So jumping back into pull, we're going to find we need another public function, and we're going to call it activate next, and we'll need to pass to it the position and rotation that we want to instantiate it at. So I'm going to say vector3 position, and I'm going to say quaternion rotation. Okay, so this activate, I prefer to call it activate next. And the return type, forgot about that. It doesn't need anything, so it's a void return type. Alright, so this function is going to be kind of weird because we're going to have to cycle through them. So we're going to cycle through them, and we're going to find the next inactive. So to cycle through, we're going to say 4, and we'll just let the default do it. We've already stored how many objects that we have. Luckily we stored it in this M, which short for member, number of objects, so we know that it's M underscore number of objects, and yeah, so that's good. Now for every single one we're going to have to see if it's active. So if the gameobjects array I is active, so the old one was just active, but that's deprecated now, so usually you knew this active self one. So if it's active, and we'll put the not before it, so if it's not active, then we're going to activate this object at the position and rotation. So we're going to say gameobjects array I set active true, true, true. There we go. And we're going to set this transform dot position to be equal to the position that we passed in, and same thing for this one for rotation, so we want to set the transform dot rotation to be equal to the rotation that we pass in. I'm unsure whether it should be activate it first and then set the transforms, or the other way around, so you can add in the comments if you find any difference between the two, but we'll just leave it at that. So activate next is our function that we want to call. In theory, the bullets themselves take control of whether they deactivate themselves, so the pool itself should just only need to activate them. To make this more useful, we might need to create a function that deactivates all of them or activates all of them, but the function, a little standalone class here, this function that I have is enough for our purposes for now. Yeah, I forgot to change that. So inside of the bullet script, rather than instantiating the bullet, what we want to do is, I'm just going to comment that out actually. Oh, sorry, I'm in the wrong place. It is in the gun script. Nearly made a big mistake again. So in the gun script, instead of instantiating the bullet prefab, we're going to do the other thing. We're going to use our pool function, so we called it bullet pool, and it was activate next, and it was the transform dot position and the transform dot rotation. So I'm kind of more or less copying this, but the bullet pool contains the prefabs, or the number of prefabs that we need. Right, so this might take a little bit of tweaking, just to be sure that it's right. It's a fairly cool concept, but it's actually quite difficult to do. So here we go. You can see what's happening is that it's creating a whole lot of particles for some reason. Okay, I'm just going to pause the video. It's fairly common mistake with this one, but when we activate, what I did is I found the next active object, and then I didn't break the loop, so it activated all of them because they were all inactive. So all we need to do is the break command in here, and you'll see this break command breaks this for loop. So as soon as it finds the first inactive object, it will set it active, and then it will break the loop. So jumping back again, this is the fun of doing things in one take. Yeah, it's a lot better. So you can see, if you look on the left here, as we fire the bullets, it's basically only getting to the first two, because the bullets are ending up hitting this thing. So if I move that, let's move it back a little bit more. I should probably move that back inside of the not playing. So you'll see now that we'll probably activate a few more of the bullets as more of them are visible on the scene at any one time, but it's pretty clear it's not going to get much beyond like the 4 or 5 of them. So maybe if you were to be a bit more efficient, you might want to reduce the number of these that are created when you create the pool. That's object pooling. Now obviously I'll take any suggestions for the next video that you want. I might just do a little showcase of when we add this to the first person controller, because the gun literally is all that's required, and all the scripts and code. The gun just needs to be added to a first person controller, and you'll be able to run around and shoot. Also we'll take suggestions if you wish to do things like maybe recoil. We could do gun recoil to get a little bit of randomness inside the gun shooting. But that's all. Object pooling is really useful. We could, if you wanted to, you could have the object pool, use the object pool, reuse it again for the particle systems, and you could have some kind of game manager that is told to create new particle systems, but it manages it through the pool. And that's the video finished. So I hope you've enjoyed the series, and please feel free to subscribe and comment, and if you've got any suggestions, also put those in the comments too, and I'll make some more tutorials for you. Thanks and goodbye.